Okay, so today we're going to cover Newton's first law, and this whole thing is really about why things move. So we've discussed how things move earlier in describing them, and so we talked about speed and velocity and displacement and that sort of thing. But so why do things move? And we've discussed how things move. Okay. We've discussed how things move. So we've talked about displacement, velocity, and acceleration. Okay, but what causes these things? All right, what causes these things to move? Okay, so before we can actually go on with this, we need to talk about we need to explain why things don't move before we can explain why they do. Okay, and so to do that, we're going to talk. We have a bowl okay, a shallow bowl of water. And it's filled right to the brim. All the way up to the top. Okay, and you are tasked with moving this bowl of water from one side of the room to the other without spilling anything. How are you going to accomplish this? How do you get things to if this thing's filled with water? In fact, we're going to demo this right here. Okay, so we're going to Okay, so as we just saw in this demo, that if we change the direction of this bowl of water, okay, change its direction, or if we change its state of motion, if we get it going or even if it's moving, and then I want to stop it, the water's going to keep on going, right? That's okay. This is the idea behind inertia. Okay, and inertia is it's an object's resistance to a change in its state of motion. and we have a way of measuring this. How much inertia does something have? How resistant will it be to a change in motion? And we call that measurement mass. Okay, so mass measures an object's inertia. But this should make sense to you guys. So if I get my massive particles of science over here, if I have these two guys, all right, and one of these is a lawn bowling ball, and one of them is a shot from shot put. They're both roughly the same size, but one of them is heavier than the other, right? Okay. It is more dense because it's more mass in the same amount of space, but one of them has a greater inertia. One of them is going to be more difficult to move just because it's heavier. Yeah? So I'm going to pass these guys around. You can okay. So you can feel those. How one of them is significantly heavier than the other, even though they're the same size. It's because it has more inertia. Mass measures an object's inertia. Okay, the units for mass. Okay, the units are the kilogram. The kg. This is about equal to 2.205 pounds. Okay, but we're going to stop using metric measurements soon. No more inches, no more pounds, no more feet. It's all going to be centimeters, meters, kilograms. Okay, so inertia is an object's resistance to a change in its state of motion. An object's mass, okay, is the measurement of its inertia, and we count mass in units of kilograms. Alex, we need you. Okay, which brings us to Newton's first law. Let's put them on the tray right back here. Newton's first, and that's ugly, so let's cover that up. Can you what? Okay, which brings us to Newton's first law. Okay, and Newton's first law is it's called the law of inertia. And I'm missing. Okay. The way that you guys may be used to hearing this is Okay, this might be the best way to explain it. Objects at rest stay at rest, and objects in motion stay in motion unless acted upon by an outside force. Okay, we haven't described exactly what a force is yet. Okay, but I will tell you that it is something that moves objects, something that causes objects to move or change their state of motion. Okay, now, this is also written with it has an equation that comes with it and some math, and so I need you guys to get this math that we're doing here. That is, if the sum, are you guys familiar with this letter, with this symbol? Okay, this is called sigma. Okay. It's called sigma, and it means the sum of, or you're adding everything that's after it together. Sum of everything after it. Okay, so if I write the sigma and then I put this F here, this means the sum of the forces acting on an object if it equals 0, then the acceleration of that object is going to be equal to 0. Okay, and so we're going to break this math down into what it means in words. So, this is the sum of the forces, or this part here means all of the outside forces. Okay, that one's pretty straightforward. Okay, if all of the outside forces equal 0, okay, acceleration is the acceleration is the rate of change in the state of motion. In other words, it's how fast something is changing its motion. Right? Is it getting faster or slower? Is it dropping to 0? Was it, how hard are you hitting the brake? How hard are you hitting the gas pedal? That's what A stands for, is the rate of change in the state of motion. And then here's equals 0 again. Okay, this is the important part. That if all of the outside forces equal 0, then it doesn't change its state of motion. You follow? So I want you to take a minute and reread this up here, and try to recognize how what happens down here is the same thing as what happened up here. That this is explaining the same phenomenon down here. All right, so we're gonna pause for a second and let you guys. I want you guys to think about that for a minute. It means sum of this. Means, yeah. It means sum of. Yeah. So the big takeaway from this is that we have we have this concept that we're going to need to carry with us throughout the whole course. And whenever we have something that stays, where things stay the same, okay, it means no change, right? If something stays, it doesn't change. Well, we need to be able to go back and forth between not doing anything, okay, and equaling 0. If something's not, if its motion isn't changing, its acceleration equals 0. If something's not moving, its velocity equals 0. Does that, you guys follow me there? Okay, that it's a surprisingly difficult concept for many students to get. Okay, that 0 means nothing, so staying means no change. But when we start applying it, we need to hold on to that idea. Okay, so that's Newton's first law. That's the big thing, and basically it means this, that if we have this big object, okay, this big old M, and we're moving, okay, in order to get it to change its state of motion is it's traveling in that direction. So in order to get it to go, in order to get it to change to, like, say, that direction, or to get it to stop, okay, it's going to require what? It's going to require a force. From its motion will require a force. Okay. If it's already moving, does it need a force to keep it moving? No. And that is an important part here. Objects in motion stay in motion. If it's already moving, it doesn't need a force to stay moving. Its motion, its state of motion doesn't change. Okay. That's it for the lecture.